Now we're going to take a look at two more sets of lines that we want to find the point of intersection. Here we have two lines and we're trying to identify this point. Now, if you have the graph, you can always just read off of this graph. So we can see the point of intersection just from looking at where axis points are. But let's say that we are just given the equations. Now we can see that these equations are not written in the form of y equals mx plus b. So we need to do a little bit of upfront work before we can use the methods that we showed earlier in previous videos. Now I'm going to show you one method where we do format it in this way and then solve for it. And then for the second set of lines, I will show you another way we can do it. Well, this first set of equations, I'm going to rewrite them in the format of y equals mx plus b. Now, first thing I typically do when I want to do this is force the constant in front of the y to be 1 or -1. It really doesn't matter. So in this case, this is -3. So I'm going to divide by 3 on both sides of this equation. So 9x becomes 3x, -3y becomes -y, -18 becomes -6. Now I can just isolate my y variable. I move it to the right. I get y is equal to 3x plus 6. Okay. And now I want to do the same thing for the second equation. I get 2x plus 2y equals 2. The constant in front of it is 2, so I'll just divide by 2 everywhere. So divide by 2, I get 2x becomes x, 2y becomes y, and 2 becomes 1. Then I isolate my y value. Get y is equal to, move the x over to the right, -x plus 1. Right? Now that I have these two equations in the traditional linear equation y equals mx plus b form, I can just equate these equations because that's forcing the y values to be equal to each other. So I got 3x plus 6 is equal to -x plus 1. 3x plus 6 equals -x plus 1. Now I want to solve for x. So I move -x to the right side, so 3x plus x is 4x. Move the 6 to the right side, so 1 minus 6 is -5. So I have 4x equals -5. Divide by 4 on both sides. Get x equals to -5 over 4, or -1 1/4. Okay, now you take this x value, and if you remember from the previous videos, we plug it into one of our equations. Now you could plug into any form of these equations. You can plug in this form, or one of these forms. It really doesn't matter. So you plug in the one that makes the most sense, and you can always double check by plugging into the other form or the other equation. If you converted the form or if you set up and solve for x correctly, all those methods will give you the same y value. So let's see, which way did I do it? I use this form right here, right? So I said 2 times x, where x is -1.5, or sorry, 1.25, that's what I have here, plus 2y equals 2, right? So now I just need to solve for y. So 2 times -1.25 is what? -2.5. And 2y equals 2. I move -2.5 to the right side, so plus 2.5. 2.5 plus 2 is 4.5. So I have 2y is equal to 4.5. And so I divide by 2 on both sides. I get y is equal to 2.25. And so that means x intersect point is -1.25. And the y intersect point is 2.25. If we look at our graph, let's see. It's a little small, but it looks like the y-axis dash marks are at quarter marks. So this would be 2.25. That matches what we say for y. And then for x, these are also quarter marks. So this would be -1.25, which is what we found. Okay, so this method is converting these equations into the traditional y equals mx plus b format. Let's take a look at our second set of equations. Here's our second set, and I could do it the same way, right? But another way you can do it is by, so the question is, what are we essentially trying to do? We're essentially trying to drop out one of these variables, either y or x. It really doesn't matter. And so we did equate these two, but another way to think about it or see is if we just subtracted these two sets of equations, right? Y equals 3x plus 6 minus y equals negative x plus 1. If you subtract them, then you get 0, because the y minus y will be 0, is equal to 3x plus 6 minus the quantity negative x plus 1. And then you can move that to the other side of the equation, and essentially you'll get this. So if I have this equation in this form, and I see the constant in front of my y values, or maybe in another form, in another problem, the constants in front of the x values are either the same constant or the same, but with a sign difference, then it's very convenient to either add the equations or subtract them, and one of the parameters, either y or x, will drop out. In this case, we have 0.25y and 0.25y here. So I want to subtract my equations, and that will get rid of my y value. That's the same thing as what we essentially did here. Which equation you want to subtract from the other, it really doesn't matter because it's an equation, so the signs will be different in the last form, but it will be balanced across the equal sign. So I'm going to subtract these two equations. So we get what? So we get this equation minus this equation. So 0.25y minus 0.25y, now the y term will go to 0. They get minus 0.25x minus negative x. So that's what this term is here, is equal to 0.5 minus negative 1. So that's how we got this equation. Now, if you don't believe me, you can always rewrite these in this form, and you can see that this equation can also be pulled out, right? Just as a convenient way, depending on what constants you have in front of your y and x variables for the two equations and how they match up. All right, so now let's clean it up, and we already have our x terms isolated on one side and our constants on the other side. So we got minus a quarter x minus so plus x. So it's 1 minus 0.25 is 0.75. Then on this side, we have 0.5 minus again, 0.5 plus 1, that'll be 1.5. So we got 0.75x is equal to 1.5. And if I divide by both sides by 0.75, this will be x is equal to 2. Okay? Again, I plug in this x equals 2 to any of these equations, and I can solve for y, right? So either this equation or this equation, doesn't really matter. So which one did I do? I use this equation, right? So 0.25y minus x, in this case, it's equal to 2. So minus 2 is equal to negative 1. So I add 2 on both sides. I get 0.25y is equal to 2 minus 1, or 1. Divide by 0.25, or 1.25 on both sides, get y is equal to 4. So the point of intersection for these two lines are x equals 2 and y equals 4. And I check on the graph, I see x equals 2 and y equals 4.